Hello student, welcome you all to online session. I am Prerana Shinde from the Department of Chemistry, S.V.K.T College, Devari Camp, Nasik. So today we are going to start with the photochemistry, the third topic of our syllabus 501. In that we are going to see the difference between the thermal and photochemical processes, terminology used in photochemistry, that is the radiant energy, what is the radiant power, transmittance, absorbance, absorptivity, molar absorptivity, path length. These terminology that we are going to see today. In that again we are going to see the laws of photochemistry, that is the Lambert-Beer's law, Stark-Einstein law, quantum mill, and which kind of detector that we used during the photochemistry. So, there are 4 types of photochemical reaction basically. First is the photosynthesis, in which the photons are used for the synthesis. Photolysis, that is a breakdown of a photon. Photocatalysis, a photon used as a catalyst, and photosensitization reaction. What are the photochemical phenomena? There are 3 basically: fluorescence, phosphorescence and chemiluminescence. These are the 3 photochemical phenomena. In that we are going to see that is the difference between the thermal and photochemical process, different photochemical laws, quantum yield, reason for a high and low quantum yield, factors affecting the quantum yield, experimental method for determination of quantum yield. Next, photochemical reaction, that is photosynthesis, photolysis, photocatalysis and photosensitization reaction. Photochemical phenomenon like a fluorescence, phosphorescence and chemiluminescence. So, what is a photochemistry is? The photochemistry is the study of chemical reaction and physical changes that result from the interaction between the matter and visible or the ultraviolet light. In that reaction, the molecules are activated by the absorbing the energy in the form which it is supplied. So, basically photochemical reaction or photochemistry deal with the, that is the matter absorb a particular light, that is maybe a visible or ultraviolet light, and the changes according to that in their chemical behavior and the physical behavior. So, this is all about the definition of a photochemistry. What is the difference between the thermal and photochemical reaction? In a thermal reaction, the reacting molecules derive the activation energy through the collision. Basically thermal reaction, in thermal reaction we can say it is a chemical reaction. Basically HCl react with the NaOH, formation neutralization reaction, formation of water and salt. In that what exactly happen, the molecule get collide with each other. Only when the molecule has an effective collision they form the product. So, this is what the chemical reaction is, which happen with the help of a thermal, or the which happen with the help of the temperature coefficient or temperature. The number of molecules that activated in this way depend on the temperature. The rate of thermal reaction however changes markedly with the temperature. As you increases, as you all know, as you increase the temperature of a particular reaction, the rate of reaction also get increases. But in a photochemical reaction, the molecule derive the necessary energy through the absorption of light with which they are irradiated. So, basically in photochemical reaction what happen, the reaction or the molecule in a particular reaction, they absorb the light and get enough amount of energy to form the product. The reactant molecule absorb light of a particular wavelength and get activated. The rate of photochemical reaction thus can be varied by changing the intensity of light used for the irradiation and is usually independent upon the temperature. As you know, the electromagnetic spectrum, that is basically high energy to low energy. You know, that is the radio frequency, microwave, IR, UV, after that X-ray, gamma rays, cosmic rays. The energy of the wave energy get increases. So, it basically depend upon the intensity of that light we used for the irradiation. That much the photochemical reaction get, the rate of the photochemical reaction depend upon the intensity of light. So, in a photochemistry, we use the different terminology in a sense of light. The first of all is the radiant energy. So, what is the radiant energy? It is defined as the energy transmitted as a electromagnetic radiation. It is characterized by the wavelength and frequency nu. Any particular waves has the wavelength and frequency, the two basic criteria. The relation between the wavelength and frequency nu is equal to C upon lambda, where lambda is the wavelength in centimeter, nu is the frequency in second, and c is the velocity of light, that is the 3 into 10 raised to 10 centimeter per second. So what are the units of wavelength? You can write it as in angstrom unit, you can write in meter, you can write. So there is a conversion, that is a 1 angstrom is equal to 10 raised to minus 10 meter, 10 raised to minus 8 centimeter. 1 nanometer is equal to 10 raised to minus 9 meter and is equal to 10 raised to 10 angstrom unit. So you can put wavelength it in this format. So electromagnetic radiation possesses a certain amount of energy. The energy of a unit radiation called as a photon is related to the frequency. Every photon has a particular wavelength and the frequency. Yes, so you can write it as a energy is equal to h nu. You can write nu as a c upon lambda. So formula will get transferred into hc upon lambda. Where E is the what? Energy of photon in ergs, h is the Planck's constant, which has a value 6.625 into 10 raised to minus 27 erg second and 6.625 into 10 raised to minus 34 joule second. So in both unit you can write into either 10 raised to minus 27 erg second or 10 raised to minus 34 joule second. It is obvious that shorter the wavelength, greater the frequency, greater the energy. As you know, the inverse relation of the energy is equal to hc upon lambda. As the energy is minimum, the lambda is maximum. The gamma ray X-ray regions are a higher energy, while the radio micro regions are of a lower energy region of the spectrum. As we already seen in our last lecture series, that is the electromagnetic spectrum, the energy, the wavelength, the frequency, that we already seen in that what is the sequence they follow. Radio frequency, after that the microwave, after that the IR, after UV visible, after that there are X-ray, gamma rays and the cosmic rays. So the energy get increases up to from left to right, that is to the gamma rays. Next is what is a radiant power? In the last we have seen the radiant energy. What is the radiant power? It is nothing but the intensity of a light. The energy per unit time is called as a power. So radiant power is the rate at which energy is transported in a beam of radiant energy. It is measured by a detector such as a photocell or a thermocouple. The radiant power incident upon cell is given by the symbol P0 and the transmitted by a cell is by P. So if you want to calculate the radiant power of a particular cell, you can write it as a P0 upon P. What is the transmittance? It is simply the fraction of incident power transmitted through a sample. It is a ratio of radiant power P transmitted through a sample to the radiant power incident upon the sample. So P upon P0 is nothing but it is a ratio of incident or a radiant power transmitted through the sample with the radiant power of a incident upon sample. You can write it as the radiant power transmitted through sample divided by the radiant power incident upon the sample, both being measured at the same spectral position and with the same slit width. So you can write it as T is equal to P upon P0, that is the transmitted and the incident upon a light, incident light. Or if you want to calculate the percentage transmitted, you can simply multiply the formula with the 100. So the formula will get percent transmission is equal to P upon P0 is multiplied by the 100. The exact opposite phenomena is what? The absorbance. It is, so formula known as the optical density or the extinction. In a microbiology, you basically read it as a optical density. In a colorimeter we have seen, in a spectrophotometer you have seen, that is, it is a term absorbance. How much amount of a light get absorbed by the particular substance or particular concentration of solution. So absorbance is nothing but the logarithm to base 10 of the reciprocal of a transmittance, where pure solvent is the reference material. So A is equal to minus log to the base 10 T. So as you know, transmittance is equal to P upon P0. Exactly opposite you can write as a absorbance, that is a P0 upon P. So absorbance is, you can define as a logarithm to the base 10 of the ratio of radiant power incident upon sample to the radiant power transmitted through the sample. A is equal to log 10 to P0 upon P. So transmittance and absorbance are the exactly opposite phenomena. In a colorimeter, in a practical, you know that in a colorimeter you set the absorbance for a reference sample or reference solution, for example water, absorbance is 0 as water is a colorless and transmittance is 100%. So, they are exactly opposite phenomena. So, basically again I would like to repeat, that is absorbance is also defined as the logarithm to base 10 of the ratio of radiant power incident upon the sample to the radiant power transmitted through the sample. Absorptivity. So, next is what the absorptivity. It was formerly known as the extinction coefficient or the specific extinction. Absorptivity defined as the ratio of absorbance to the product of length of optical path B and the concentration of a sample. So, molar absorptivity is equal to A upon B.C. That is the absorbance divided by path length into the concentration. It is also called as a specific absorbance because it is the absorbance of a solution of unit concentration and unit path length. Path length is nothing but the diameter or with which you cuvette you used in that particular practical, that is nothing but the path length. The path length is always defined as the centimeters and the concentration in grams per liters. So, absorptivity is a measure of the ability of sample to absorb the light. So, next is the molar absorptivity. It was formerly known as a molar extinction coefficient or molar absorption coefficient. Molar absorptivity, that is epsilon, is the product of absorptivity and molecular weight of a material. So, molar absorptivity you can write it as a epsilon is equal to molar absorptivity into the molecular weight, or you can write it as a upon Bc into m. So, m is the what? Molecular weight of a substance, and the dimension for the molar absorptivity is a liter per mole per centimeter. These are the unit for the molar absorptivity. Next is the path length. It is the internal thickness of the cell in which the test is taken. The cuvette you use during your practical, that is nothing but the path length, which is approximately equal to the 1 centimeter always. So, this is all about the basic, that is a molar absorptivity, path length, absorptivity, absorbance, transmittance, radiant power and the radiant energy. So, this kind of terminology we use in the photochemistry. So, next we are going to fundamental laws of a photometry. See here, when a monochromatic light is incident upon the homogeneous medium, the one single medium we can say homogeneous, a part of radiant power incident light is reflected, a part is absorbed by medium and remaining is transmitted. As you know, when you bombard a particular amount of light to a particular sample, there are three different phenomena occur. One is the reflection, one is the transmission and one is the absorption. So, this is what the law of photometry. Here is also defined as that as a when a monochromatic light is incident upon the homogeneous medium, a part of radiant power of the incident light is reflected, a part is absorbed by the medium and remaining is transmitted. So, these three different phenomena can occur when you bombard a particular amount of light on that sample. So, here they have shown you the PR is a reflected radiation, P0 is the incident radiation, medium of concentration and the large or the P can denote it as a transmitted radiation. So, P0, that is the incident light, is basically sum of the P, that is a transmitted radiation, PR, that is a reflected radiation, and P alpha, that is a medium of concentration. So, radiant power of incident light, PR is a radiant power of reflected light, P alpha is a radiant power of absorbed light or PA, P is a radiant power of transmitted light. As PR is very small and hence can be neglected in comparison with the PA and the P, thus equation become P0 upon P0 plus PA. There are again two basic or fundamental laws of photometry, that is a Lambert law. It relates the radiant power of absorbed light with the thickness of medium. So, Lambert put a law that in 1760 that the radiant power of absorbed light is related to the thickness of medium. Beer's law in that stated as it relates the radiant power of absorbed light with the concentration of medium. So, Lambert, the thickness of medium, in the case of Beer, the absorbance is related to the concentration of medium, and the combination of these law is known as a Lambert-Beer's law. So, basically you can write it as a, when a beam of monochromatic light is allowed to pass through a transparent medium, the rate decreases of a radiant power with the thickness of medium is directly proportional to the radiant power of a incident light. Or mathematically you can write it as a minus dP upon dB is directly proportional to P, or minus dP upon dB is equal to K1P. K1 here it is the rate constant or the constant of proportionality. So basically you can write it as a, or you can read it as a, the absorbance is directly proportional to the thickness of a medium. Which kind of medium you have used? So rearranging the equation, you can write it as a minus dP upon P is equal to K1 dB. So integrating above equation with the limits, that is B equal to 0 to B and P is 0 to P. So by taking limits for this equation, you can write it as a by taking the minus sign out of the integration, that is P0 lower limit to the higher, dP upon P, K1 dP. So 1 by P, that is a ln P, the integration rule for the integration. Ln P, by putting the limit P0 and P, you can write it as a ln P upon P0 is equal to K1B, ln P0 upon P is equal to K1B. By taking the log to the base 10 or converting the natural logarithm to the log 10, you can multiply the equation with the 2.303. So 2.303 multiply log 10 to the P0 upon P is equal to K1B. So rearranging the above equation, log 10 P0 upon P is equal to K1. So here from the LHS side, the 2.303 will get to the RHS side, which is again the in the divide. So you can write it as a log to the base 10 P0 upon P is equal to K1 upon 2.303B. So you can write P0 upon P is nothing but the absorbance of a light, as you already learnt in our last session. So A is equal to K1B, K1 upon 2.303. So where A is absorbance, log 10 to the base 10 P0 upon P, K1 is, you can write it as a K1 upon 2.303. So here in above equation, we use the small k. By substituting the K1 upon 2.303 with the capital K, we can arrange equation it as a is equal to K1B. So this is the equation for the Lambert's law. So in general, we have seen the Lambert's law. When a beam of monochromatic light is allowed to pass through a medium, absorbance is directly proportional to the thickness of medium and the concentration of the absorbance species. So this is a general statement for the combination of a Lambert's law. Basically what you have learned, Lambert states that the absorbance is directly proportional to the thickness of medium. Thickness, the cuvette you used in your practical, nothing but the what is the thickness of that cuvette. Beer's law states the absorbance is directly proportional to the concentration of absorbing species. So this is all about the Lambert's law. So what we have seen today? We have seen today the which kind of different terminology used in photochemistry. What is the difference between the thermal reaction and photochemical reaction? In a thermal reaction, you use as a temperature as a basic parameter. As you increase the temperature, the rate of reaction will get increases. In a photochemistry, you use the basically the photons, different photons or the wavelength with which you are irradiated with the sample. So as such the yield get increases. In that you have seen the what is the radiant energy, what is the radiant power, absorbance, transmittance, absorptivity, molar absorptivity, path length. So these are the factor which will get affected, which will affect on the absorbance of that particular sample. In that we have seen the Lambert's law, the combination of Lambert's law, equation in that we have seen. So this is all about the today's session. So assignment for, so what is a phosphorescence, fluorescence and what is a Lambert's law. So we already discussed these 3 points. So thank you.